Namaskar, my dear friends. Let us design and simulate boost converter. So what will happen is you already know the configuration of boost converter is we have a input voltage supply here and we have one inductor which is going to charge and store the energy. So during the on time what will happen is this S1 will be closed and this guy will be charging. Understood? And during the off time like this switch is closed, this switch is open, in that case the current will flow from this direction to this direction. So in simple form you can understand the energy stored by this input supply as well as this inductor both put together is going to boost the output, and this is how my V output will be greater than V input. Now it depends on your understanding or on the formula, like what will be the value of V output. So that actually depends on V input into 1 by 1 minus D, where D is your duty cycle, which will be called as T on time divided by T off time. Okay, sorry, T on time divided by total time period T of this particular switching frequency of this particular switch. So as you can see, let us say we have designed this particular boost converter in LTSpice and we have an input voltage of 5 volt and we want the output voltage to be 15 volt. Okay, so you can see by putting the duty cycle 0.67 you are going to get V output is equal to 15 volt. How we will calculate that? Let us say switching frequency is 25 kilohertz and we will do that. Okay, so before that what we will do is this is the input voltage, this is the inductor, and this is the switcher that is going to make this happen. And this is one diode and output capacitor and the load resistance which we have kept it at 1 ohm. All right. So why don't we do the simple calculation for this particular entry? Okay. So let us say, or let us say we change the parameters. Okay. So we have V input equal to 5 volt. V output we want it to be 15 volt. Okay. And let us say my frequency FSW is, let us say we will increase it to 50 kilohertz. Okay. So what is the expression for V output? That is going to be V input into 1 by 1 minus D. Okay. Now if we substitute the values of this, we are going to get 15 is equal to 5 into 1 by 1 minus D, and this is how we are going to get 3 is equal to 1 by 1 minus D. Understood? Because 15 by 5 is going to be 3. Now in that case we can get 1 minus D is equal to 1 by 3, and D you know already what is that? Duty cycle, which is going to be 1 minus 1 by 3, that is going to be 2 by 3, or 2 by 3 is nothing but 0.67, which will be 67% approximately. So this is, let's say, one design. Another design if you want to do quickly, let us say my V input is equal to 5 volt and V output we want it to be 10 volt. So what will happen? What will be happening? I mean, what is the requirement of my duty cycle? So what will happen is, let us say my frequency of oscillation or frequency of that switching is 50 kilohertz. All right. So in that case, my V output is going to be V input into 1 by 1 minus D, and from there we are going to get 10 is equal to 5 into 1 by 1 minus D, and this is how we are going to get 2 is equal to 1 by 1 minus D. From here we are going to get 1 minus D is equal to 1 by 2, that is 0.5, and from here we are going to get duty cycle is equal to 1 minus 0.5, that is 0.5 or 50%. What is the significance of this particular duty cycle values? So we will calculate that. So why don't you do one thing? What is the time period of this particular frequency? 1 by f, that is going to be 1 by 50 kilohertz, that is 50 into 10 to the power 3. So from there we are going to get time period is equal to Let us say we'll put it 10 to the power 6 by 5 into 10 to the power 4. 5 into 10 to the power 4 microsecond, because we have multiplied it to 10 to the power 6. And from there we are going to get 20 microsecond. Now, if my duty cycle is 50%, then T on by T is equal to 20 microsecond. So from there, sorry, we have T on by T is equal to 50%, that is 0.5. So from there we are going to get T on time is equal to 0.5 T, that is 0.5 into 20 microsecond. Okay, so that will be 10 microsecond. It means my on time is 10 microsecond and total time period is 20 microsecond. So this is how you will achieve your duty cycle of 50%. So why don't we simulate this and we try to understand like whether the output comes to this or not. So all these, like two simulations we will see. One will be 5 volt to 10 volt and one will be 5 volt to 15 volt. Okay, so I have designed this particular circuit in LTSpice. You can see previous videos as well how to put the like connectors very easily. So let me give you an understanding quickly. Like press V for voltage, okay, ground, G for ground, okay, and let us say you want to put inductor, so that is L for inductor, okay, then you want to put D for diode, and then you can put a C for capacitor, R for resistor, and this is how you put all the components in this circuit, right? So right now I don't need it, so I'll just like delete them. Now after wiring this, what we are going to do is, as you can see, we are going to have set our input voltage to be 5 volt. Inductor I have taken 100 microhenry and capacitor output I have taken 100 microfarad. The output load we have taken 10 ohm, and what we are going to do is we are going to set the pulse at this particular switching frequency. So I have put a net name, you can see it is connected like this, okay. So right click it and you can see we have pulse input independent voltage source. The on time I have kept 5 5 volt, and T on and T period you can see we have put 10 U, that is 10 microsecond, and 20 U, that is 20 microsecond, okay. Now let us run it and this see what is going to happen. So if I go to configure analysis, it is asking for a stop time and start saving data. I'll put it 10 microsecond as 0, okay, like start saving data from the beginning. So this 10 millisecond it will run. Now let us run it. So as you can see, I'll just click it only the output voltage. Let us run it again. So as you can see, my output voltage is settling down closer to 9.6 volt. Actually it is little bit more designing parameters is needed. It's not that easy to get directly 10 volt, okay. So you can see it is closer to 10 volt according to our design. All right, and you can see the input voltage is my 5 volt here and output voltage is closer to 10 volt. So this is how the boost converter has been designed, okay. If you want to see the switching curve, so before that, why don't we see the inductor current? What is the current flowing through the inductor? So the current flowing through the inductor is red color. You can see it is closer to 1.8 amperes. Okay. Why? Because output voltage is around, like 9.8 or something. So this 10 ohm is there now. So according to that, it is giving you the output current. All right. Now, if you have a requirement of how do we get particular, okay, I didn't tell you the other one. Right click it. We wanted to get the output voltage to be 15 volt, right? So why don't we do one thing? We needed 67% of duty cycle, right? So in 67% of duty cycle, we will be requiring how much? It will be around 13 microsecond, okay? So 13 by 20 will be around how much? 2 छक 12, 2 पचे 10, 13.5 or something. 13 is fine. Now let us run it and see what is the output voltage that is going to come. So it is going to closer to 15 volts. See, it is 14 volt. If you want, you can increase the duty cycle to increase your output voltage value. So let us increase it to 14. And if you see, my output voltage is getting settled to 16 volt. So we have to, like play that exactly from this particular calculation that we did just now. Okay. So from here, my time period will be how much? 1 by 50 kilohertz. That was actually 20 microsecond. So you can see T on by T is going to be 0.67. So from here T on will be 0.67 multiplied by 20. So that is going to come up as 0.67 multiplied by 20 is equal to 13.4 microsecond. So if you put exactly 13.4 microsecond, your output will be 15 volt. So that's the reason we are struggling. The output voltage is not settled to 15 because the on period is more, right? So 13.4. Now let us run and see. Yes, so you can see it is very, very closer to 15 volt. Okay. That's all. So this is how you design and simulate your boost converter circuit in LTSpice. So if you do have any questions or any understanding that is needed regarding the boost converter simulation and output, you can put down your questions in the comment box and take a screenshot of this particular, like parameter so that you can design your own boost converter of your desired input voltage and output voltage and the switching frequency that you want to design, right? So this is first one. The second one can be this, like input voltage, output voltage, and what is the like duty cycle that will be needed based on the like on time and total time period of the switching converter, right? So all right guys, thank you.